As I mentioned before, bagging is like you have a set of training data. Let's say you have a set of 1,000 training samples. Then what you did is like you do the bootstrapping or sampling with replacement. Let's say you may be sampling 100, 100, 100, maybe, I don't know, like 1,000 times. Then you get 1,000 trees. Then maybe at the end you can get some average result for your regression, or you can do majority vote between these three to get the classification result. So that's pretty much bagging. Like there's no complication as to how they do the work. It's just that. Yeah, and this is like the mathematical equation. I think one of the questions that people would start to ask is like, then how many times did you do the bootstrapping? I think this one depends on the distribution of your data set. Are they very well structured? I mean, are they so structured or are they rather unstructured? If they are unstructured, I think you can do the subsampling only like maybe 10 times, 20 times, that should be fine. But if your data is highly structured, you tend to have to do it multiple times so that your so that your tree wouldn't be too correlated to one another. And as you can see here, this is like for each of the tree. I use the subscription B here to denote each tree that I get from bagging. Yeah. Actually, the bagging also introduced us something called out of bag. It is because it is observed that, especially if you do some kind of majority vote over the bag tree like this, if you do majority vote, that means that there are some of the trees that does not give you the kind of answer that most of it would provide. Let's say if you have 100 trees and maybe 32% of that say that this input sample should be in class A, but maybe for the rest 68, maybe it suggests maybe different classes. Then they become some kind of minority. But the thing is, what they found is that usually these minority will tell you what your performance would look like if your testing sample does not align with your training. Because every decision that is made here are actually the majority vote of your training label data. So whatever decision that is made that is not aligned with the majority is actually said to be the out of bag decision making, or sometimes we call it out of bag samples. So they are like the according to the textbook, it said that about 1/3 of the samples, or maybe 1/3 of the tree that you've learned. Actually, this is like more like the back samples, the bootstrap samples. It's like 1/3 of your bootstrap samples will not provide whatever the majority said. So actually these samples, or these bootstrap samples, are used to make your tree anyway. It could be like 1/3 of here does not align with the other 2/3. So these 1/3 are these three. So what this 1/3 representing is like they're representing the performance of your tree-based algorithm that does not align with your assumption. or on the other word, they are the training samples that does not say it according to whatever the majority. And actually you can use this 1/3 to visualize and then how far should you sample the tree for. For example, if you look at this graph, we actually provide you the 2 line. Up here is the result from just using the backing technique. The one below here is using random forest. Since random forest and backing are very similar in the sense that they actually, sampling the data samples like that. And of course, they will end up with many bootstrapped trees. Thing is, if you visualize those trees that tend to not align with the others, if you bootstrap it with, let's say, 10 times, you probably get some performance that is worse than what it would provide if you average all the results. But as you bootstrap more, your out-of-bag will start to perform like those samples that align with majority. And perhaps it could even be better than, let's say, it could perform better than if you were to average all the results as the one above. So these are like a performance. Is the performance of the out-of-bag trees. So yes, the out-of-bag trees could perform better if you have gathered enough bootstrapped trees, or if you have bootstrapped it many times. Or you can think of it as if you were to bootstrap it only a few times. That is similar to if you were to do something like hold out in cross-validation. But if you bootstrap it multiple times, it would then start to perform like a leave one out. Because whatever you get in each of your subsample data will start to be very similar to your other set of training data. Shall we go? Okay. Okay. So as I mentioned before, that what is remaining unchanged in the bagging algorithm is the fact that we will not change the features, unlike the random forest, because we didn't change the set of features and the order of sorting. So very likely what you get is that if you have bagged multiple trees, let's say up onto maybe 1,000 trees, what you get is that you probably get some kind of decision tree that are having the node that are making decision according to the same order of the feature set that you have, because you sort along the same set of feature, and if you use the same way of sorting the feature, but all you change is like the training samples. What could be different is that, for example, it's like this one, you probably make decision using X1, but for the other tree, it may not be the left node, it could be the right node. Here there may be some differences in how the thresholding would work, because if you change your training data, that means you very likely get a different thresholding value. So sometimes when you back your tree, you may get the tree with different, like different side of decision making, but definitely the order should still be the same. Or you can also get a tree that is not having the same length. Let's say this one maybe only have x1 and x2, stuff like that, and that's it. It may not go as far as maybe xn. It is possible as well, like you may be having the tree that is shorter than the other, but the order should still be the same as the feature dimension. Thing is, with this, let's say if you are able to construct the tree decision, let's say if I have x1, x2, maybe up until x10 here like that, and actually because as I was making the tree, I should be able to collect the value of the variance reduction for each splitting that I made. But the thing is, if we are able to average the splitting along each feature dimension, like you get the variance reduction along the way. And if you collect this value, you may be able to find that actually, for example, the jump between x1, if we use x1 as the parents and x2 as, let's say, the child, and then we further make decision based on x2 again, we may find that actually there are a lot of jump between x1 and x2 in terms of variance. That means there is high variance reduction. And after x2 up until x10, the variance reduction may be somewhat similar. So that means that, maybe the important features is just x2, and whatever you get after x2 up until x10 may not be that important. So that means you can use this fact to select the feature based on the variance reduction or information gain if you collect this value. But of course you have to collect them, because the one up here is like your very very first parents, and then child, and then great child. Yeah. Another thing about this fact that is, if you sort over like sorting over the feature like that to make the splitting, what you get is like you may be able to derive some probabilistic relationship. For example, if you get x0 to have like a certain value, then you able to find that, oh, actually x1 is very important, as well as x0 you may be having a very high variance reduction. That should also mean that prob of x1 given x0 is high. Like they may be having high correlation towards one another, stuff like that. So it is like the decision tree would enable you some kind of probabilistic relationship to be constructed according to how decision tree is made. But this is more like the fact that it's kind of like emphasizing the fact that decision tree is building the tree based on relationship between the input features that you have. So that is like a core idea. The next topic is random forest. So maybe can I please have like 3 minutes break?